Hey everyone, welcome back to Mind and Maths with Amna. Today I'm going to solve a few more questions. I believe 2 questions on sampling distribution. These questions are taken from the Statistics 1 study guide provided by University of London for their EMFSS courses. This is chapter 4, Random Variables, the Normal and Sampling Distribution. In the first worked example, we have a population with 4 elements. So we have the population element A and B and C and D, and each has a value 3, 6, 9, 12. Okay, they want us to calculate the population mean and variance. Okay, the population mean is just going to be summation of each value divided by the total number of entries, which in this case is a 4. So 3 plus 6 plus 9 plus 12 over a 4 is going to be our population mean. And we'll just have to take out our calculators at this point, and the answer will amount to a 7.5. Okay. The population variance is basically the summation of each entry with us deducting the mean from it, and we whole square it and we divide it by total number of observations. So we basically have a 3 minus a 7.5 whole square, then a 6 minus a 7.5 whole square, then a 9 minus a 7.5 whole square, plus a 12 minus a 7.5 whole square, and we divide through by total entries, which is a 4, and the answer will be an 11.25. Okay, next question. They want us to write down the sampling distribution of the sample mean for samples of size 2 drawn without replacement where order does not matter. So basically they're talking about combinations. Okay, so we have a population of population has a size 4, and they want each sample to have a size of 2. So small n is equals to 2, capital N is equals to a 4. What will be the total number of samples that we'll be able to take out? That will be a 4C2. So that is a 4 factorial over a 2 factorial over a 2 factorial, which is a 4 into 3 into 2 factorial. The 2 factorial cancels out and 2 factorial remains. And that's just a 2, right? So 2 2s are 4. So we'll be able to create 6 samples. Okay, so we have the first sample. It can be what was the total population? Population had A, B, C, D. Okay, A, B, C, D. Okay, so the first sample can be AB, second can be AC, then AD, then a BC, BD, CD. And we know that each A takes a value of 3 and B takes a value of 6. Then A takes a value of 3 and C takes a value of 9. The sample AD will have values 3 and 12. BC will have 6 and 9. BD will have 6 and a 12. And CD will have a 9 and a 12. So the average of each will be 3 plus 6 over 2, a 3 plus 9 over 2, and so on. So this is going to be a 4.5. This will be a 6, a 7.5, a 7.5, 9, 10.5. Okay, so the probability distribution of the sample mean will be as follows. It can take the value 4.5 with probability 1 by 6, the value 6 with probability 1 by 6, the value 7.5 with probability 2 by 6, the value 9 with probability 1 by 6, and the value 10.5 with probability 1 by 6. So this is the sampling distribution of the sample mean. Let's see what they asked us. They want us to calculate the mean of the sampling distribution and the variance of the sampling distribution. Okay, so the mean is the expected value of x bar, which is going to be a 4.5 multiplied by 1 over 6 plus a 6 multiplied by 1 by 6 plus a 7.5 multiplied by 2 by 6 plus 9 multiplied by 1 by 6 plus 10.5 multiplied by 1 by 6. Basically, what we've done is we've just used the formula, which is the summation of each value multiplied by the probability of taking on that value. Okay, so we'll have a 4.5 plus a 6 plus a 2 multiplied by 7.5 plus a 9 plus a 10.5 over a 6. I don't want this to be neat. Okay, which is a 45 over a 6, which becomes a 7.5. So this is the same as the population mean as well, 7.5. Okay, the variance of x bar is going to be summation x bar square over an n minus expected value, or let me just write it like this: expected value of x bar square minus expected value of x bar whole square. So this will become a 4.5 square plus 6 square plus 2 into a 7.5 square plus 9 square plus 10.5 square over a 6 minus a 7.5 square, and the answer will become a 3.75. Okay, next question. This is a practice problem. It says the following 6 observations give the time taken in seconds to complete a 100-meter sprint by 6 individuals. So individual A takes 15 seconds, individual B takes 14 seconds, and so on. Individual F takes 15 seconds to complete a 100-meter sprint. Note that this is the population. Okay, find the population mean and population standard deviation. So population mean is just going to be 15 plus a 14 plus a 10 plus a 12 plus a 20 plus a 15. So we've added all the values and we're going to divide it by total number of observations, which was a 6. Okay, so we'll get an 86 by 6, which is a 14.33. Okay, moving on. The population standard deviation is basically the under root of variance. So let's just calculate population variance first, which is going to be 1 over an n summation xi minus mu whole square. Okay, so basically we'll have a 15 minus a 14.33 square plus a 14 minus 14.33 square, and so on till the last entry, which is a 15 minus a 14.33 square. Okay, and total number of observations is 6. Yeah, so this becomes a 9.56. So the standard deviation of the population is a 9.56 as under root of it, and we'll have a 3.09. Yeah, start. Okay, the next part is that they want us to calculate the sample mean for each possible sample of 2 individuals, of 3 individuals, of 4 individuals. Okay, so in part B, remember the population. In the population we have A, B, C, D, E, F, right? And they take these many seconds to complete the race. Okay, so let's just put up this part. Okay, so we have a total of 6, and we want to create initially a sample size of 2 individuals, right? So how many samples will we able to compute? It's going to be a 6C2, and this is just a 6 factorial over a 4 factorial multiplied by 2 factorial, and it becomes 15. Okay, so we'll be able to calculate make 15 samples. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So let's start creating a sample. The first sample can consist of individual A, B. The second could be A, C, then AD, then AE, then AF, then BC, BD, BE, BF, then a CD, CE, CF, then a DE, DF, and lastly EF. And they want us to calculate the average, the mean of each sample, right? So individual A took 15 seconds and individual 2 took 14 seconds. So we need the average of these two, which is basically going to be a 14.5. Again, individual A took 15 seconds to complete the race, individual C took 10 seconds, and we need the average because we want to compute the sample mean. So we'll have a 12.5. We keep doing this for each and every sample. So we took out 17, we took out 15 samples, and we want to find out the average of each. Okay, taking the calculator out, we have a 17.5, then a 15, then a 12, then a 13, 17, a 14.5, 11, 15, a 12.5, a 16, a 13.5, and a 17.5. So the first sample had an average value of 14.5. The second sample had an average value of 12.5, and with this we can actually create a sampling distribution. Okay, but the nice part is that if I take the average of all of these, so if I take a 14.5 plus a 12.5 plus a 13.5 plus, like if I add all the entries with all the samples that I've taken, so I'm adding all the averages, So basically I'm taking the average of an average, okay? And because we had 15 entries here, this should actually be exactly equals to the mean of the population, which was a 14.33. So this should give a 14.33. The reason is when x is normally distributed with mean mu and standard deviation mu square, sigma square, the sampling distribution of sample mean should also be normally distributed with mean mu. So we do expect the average of when we're finding the sampling distribution of the sample mean, it should have the population mean in its expected value. Okay, so on yeah, in the second part it wants us to create a sample of 3 individuals. Okay, so the population is 6 individuals, we want a sample of 3 individuals. So how many samples will we be able to create? It's going to be 6 factorial over 3 factorial, 3 factorial, and we're going to be able to create 20 such samples. Okay, so 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20, and the first could be an A B C, then an A B D. As you can see, this is quite time consuming. You can take your time to calculate all such possible scenarios till, for instance, the last. You can just write the last two, and then you take out the average of the basically the mean of each sample. So for instance, A took 15 seconds, B took 14 seconds, and C took 10 seconds. So the average value will be, we're going to divide by 3 and you'll get a 13 here. Similarly, we'll add a 15 and 14 and 12 and divide it through by a 3 and you'll get a 13.67. So you keep doing this for all the samples, and for let's suppose it's a 15.67 here. So when you now add up all the averages that of each sample that you've calculated and you divide it by total entries, which is basically 20, it is going to give you a 14.33 again. Okay, so the sampling distribution of the sample mean, the expected value when you calculate it, has to be equals to the population mean as well. Okay, actually at this point, if you want, you can actually even state the probability of each taking its individual value, which we know is just a 1 by 15, a 1 by 15, and so on. So when you're taking out the expected value, what you're doing is you're just multiplying each entry with the probability and you're adding them all up. It amounts to the same thing as taking the average of all 15 entries. And for the last thing, they want us to take 4 individuals. So they want us to create a sample of from 6, we want a total of 4 individuals, and we'll get a total number of samples. Let's see, when we make this calculation, you're going to get 15 possible samples. So you'll have 15 possible samples here, and you make all these combinations, and when you get the average of each sample, you take the expected value of that, and that's going to be the same as population mean. So the gist of this is that if you have a population of size n and you create, in this case it was 6, and you create samples of size, let's suppose you took a sample of size 2, then you created samples of size 3, and you create samples of size 4. So you took these samples of these sizes, and then you created, for instance, in this case you ended up with 15 samples. When you took a sample size of 3, you had 20 samples, and when you took a sample size of 2, you had 15 samples. So for each sample you can create a sampling distribution. For instance, in this case, the mean of each, and you could write the probability of each mean as, for instance, we had a 14.5. Okay, so a 14.5 occurred how many times? Let's see. 1, 2. Okay, so the probability of it occurring was a 2 by 15. Moving on, 12.5. 12.5 occurs only twice. So we have a 2 by 15 chance of 12.5 occurring. So similarly, you can just write all possible values that the mean takes, and you write down the corresponding probabilities as well, and that just gives you the sampling distribution. And then it's easy to just calculate the probability, the expected value, because the expected value of the mean is just going to be summation of the mean, and you multiply it with the corresponding probability, right? And then you will end up with a 14.33, which is going to be the population mean. So that's it for sampling distributions. I hope this lecture was beneficial, and I actually didn't bother to do all of this calculation, but you should do it at least once. It is a bit tedious, but it does help you understand the concept really well. So this is it for now, and I will see you in the next one. Take care.